It's nice. Okay, there we go.
I had that on my mind, and I needed to vent to somebody who understood.
Aaron
loves me, but
I'm excited to talk with another adult. So
it's hard when you have kids, huh? That'd be hard. Home with them all day.
It's great. It's great. I love it.
It's awesome.
Okay, so number 3.
I put 2.
Yes.
Okay. For number 4, I put 1.5.
Yes.
And then number 5, I put 1.
Yes.
Is that the right?
Yeah, you got it right.
Did I do that right? Okay. All these ones get right. And then, okay, so I kind of had a hard time. I looked in the book for the instructions for this one. I put hot dog shape.
Yeah, you're right. So did you see they had like pictures of the hot dog and the banana and the hamburger for lesson 22? Like towards the
So what I did, it's in the, it's in the book.
Yeah, in the book. You're fine. You got it right. The answer's right.
I just did this. It was hot dog. I did the scatter plot thing. Yeah. And then I assumed it was hot dog because it was shaped different. Bananas, they're usually curved. Yes. Yeah. And the hot dog, the way the scatter plot, that's what I did. Yeah. So there probably was multiple.
You got it right. And so then, did you get number 7?
Oh. Yep. So for number 7, I put, based on the shape of the scatter plot you produced in the last question, what can you say about the appropriateness of using simple linear regression to model these data? I put this B.
So it's the first one, it's A, and in lesson 22, the book, where it has those 3 pictures, it will say under the hot dog the same word, simple linear regression is appropriate. Yeah.
So there's a visual representation.
Yeah, so right in the book.
Okay. Did I read chapter 22? I'm going to pick that up really quick, if that's okay.
It's towards the very bottom of the chapter.
I think I only read 21. Why didn't I read? Maybe I did read 22. I'm sorry, my computer.
Going on, so no worries.
You're so nice, Christine. Okay, I'm going to try to hurry. Sorry, my internet's super slow. I'm not very patient with it.
Marjorie, you're fine. You don't have to hurry.
Okay.
I'm pulling it up myself.
So we have that as a reference. That might help me because there was a few problems. There were. Come on. It's coming. Okay, here we go. Let's look for it in the book. Oh, here we go. I remember seeing this. I just skimmed through it because I was like, oh, pictures. Let's skim through it.
I know, I just went. Yeah,
I shouldn't have done that.
Yeah, so if you see where it says the patterns right there on 3, it tells you the decision.
There they are.
Yeah, your decision, and it gives you the decision, which is your number 7.
Okay. We used SPSS, right?
Yes.
So what I did, I just made a random scatter plot and then I guessed. So it's good that we have that nice little table there, so I can know for certain that was right.
Yeah, exactly. It was the same way.
And how many observations are in the data? Is this also in the book as well?
So I
put 2.
It's actually 139.
Okay.
So I did a histogram off of the data that we have, and it's your N. It's what you, your N was 139, however many.
Oh, so you did a histogram. How did you know how to do that? Was that in the book?
No. It's just the only way I can figure out, like, I can never read the graphs. I have a horrible time with, like, reading in the graphs, but if I see the numbers, there may have been a way it may have told you. I couldn't find it in the book how to figure out how to find the observations, but I knew the observations were how many people or manatees or whatever we were trying to find. So I knew that I could find that.
And the histogram represents that.
Yeah, so the histogram, since we're doing the math, the math self-efficacy, if you just did a simple histogram, it gave it to you.
Okay, so when it says observations are in the data, use the histogram method. Okay.
Yeah, I mean, I'm sure there's other ways, but that's what I did, and that's the answer.
Yeah, you can eat the potato salad, honey. Yeah. Okay. The wires. Is this the same concept? There's a
So this one was hold on. I see. I just have to remember how I got it. This is not the histogram. This was where you did the analyze, regression, linear. Let me see if I can find it. This is in the book.
Is it y hat equals BO plus B1X?
Give me a second. Sorry, I gotta find my. Oh, it's right here.
Oh, that's okay.
Number 9. No, this one you actually have to use your SPSS.
Oh, okay.
So do you have that open on the math efficacy or whatever it is?
Click on it.
And then I can tell you how to get there if you want me to. So it's
I think I made some notes here.
yeah, so
is this for SPSS instructions to predict the value of y for any specified value of x?
that might analyze regression linear. Yeah, they look like they're the same. That I was looking at the regression coefficients, but yeah.
Okay, so
yeah, analyze regression linear. Yeah, it's the same. So yes, that formula.
So is this one where you scroll down to the bottom and you put the number?
I don't, not yet. That's on like the next one.
That's for the next one. Okay, so it's the other one. Yeah, so it's instructions for the regression coefficients.
Yeah, that's.
So I think I did. Oh, I did this. I just didn't know what y was in the bar chart.
Yeah. So it is. Sorry. I got it all together.
Sorry, I'm doing it.
No, you're fine. I just was trying to find the actual paper. So it's your constant and your confidence rating mean of your coefficients.
Mm-hmm. So, and they wrote down in there which one represents what here.
Yeah.
So confidence is our explanatory, and the score. I wrote this down. Okay, here we go. Our explanatory variable is the x. So explanatory variable, our confidence data, and that's our independent, and the score is dependent.
Correct.
And then
at this point you want to click your OK.
And then you click OK, and then our box comes up.
Yeah.
Okay, here we go. And then we've got here, okay. So I'm sure they showed it in the videos, but I'm not patient enough. I don't like videos. I have a hard time with
You're fine. So it's your coefficient.
Standardized coefficients is constant y.
Yep.
The constant b.
The 18.69.
Yeah, is that it?
That's number 9. Yes.
Oh, okay. So I had it right. I just didn't know what number.
Yeah, you got
18 it. That's good. I'm getting it. Okay. 18.6. So it's 18.69.
Correct.
And is that what you put and it was good?
Yes.
Okay. And then what is the slope? The slope is, see if it's not spelled out. Is the confidence rating mean B?
Yep. It is. It's
12.6. I'm going to write this down.
Yep, because that your slope is the same thing as x.
Right. Right. So slope is the same. So I'm just going to write this down really quick. Slope is confidence rating mean. B, and then constant is B, 18.69. That's our y-intercept. Okay. Now the one we're having a hard time with, so that's 18.69. Oh, wait, sorry.
You're fine.
Okay. It's 12.69. Okay. 12.69. There we go. Okay. So this is a formula.
Yep.
I like these kinds of formulas. These make me not upset.
Me too.
These aren't p hats. These are y hat equals bo plus b1x, right?
Correct.
Okay, so we put, let's see here. I'm skipping 9 way. I think we did 9, and then we're doing 11. So we do y hat equals bo plus b1x, and we have x equals 4. So bo and b1, I wrote down what they mean. If I know what they mean, then that might help me remember which ones those are.
Yep.
Is that, oh, our y-intercept and our slope.
That's right.
So we put in BO is, the notes from the book are a lot easier than the notes from the videos.
Yeah.
I wish I could like do everything I learned, like what was most effective. Like, like I don't want to retake the course, but you know what I mean? Like the things you learn, like, man, that would have really been helpful to know at the beginning of the semester, but.
Yeah, I know.
Like, man, I wish I learned something new. Sorry, I keep saying sorry. I do that when I'm.
Oh, yeah, don't worry about it.
What's wrong with me today? 18.69. Okay.
Yep.
There's 18.69, and then there's 12.69, and then y-intercept is this one, and then the slope is this. And then BO is 18.69, and then B1 is 12.69, and then you solve. So
yes.
I can solve that quickly. Is 18.69 plus 12.69 times 4, and then I'll just get my calculator really quick. See, calculator.
So
there we go.
Number 10, or make sure that, I don't know if it's going to make a difference, but it's 12.695 and not 12.69. So you might want to make sure your 5's in there.
Okay. Thank you. Okay. And then, so should it be 12.695 times 4?
Correct.
Times 4. Okay. And then we've got that plus 18.69, which is 69 point. This is 69.47. Okay. So we've got
You got
69.47. Okay. And then 12. Wait, this is the one we were having our time with. So I'll help. Let's see here. The confidence data resulted from students evaluating their confidence for each question on a scale of 1 to 6. What is the maximum predicted value of y for these values of x? So if we look at the book, so they're saying we can use 6. Data results from students evaluating their confidence for each question on a scale of 1 to 6. What is the maximum predicted value? So maybe we could find in the book predictions here, anything about maximum predicted value and the rules regarding it. Value. So I hope this is helpful what I'm doing.
Oh, yes, you're doing good.
This is helpful because that's what I usually do. I find keywords in the question and then see if there's anything in the book at all that corresponds with it.
Yes, Janine, I just gave up. I was like, okay, I'm done.
Let's see here.
Let's see.
This looks interesting. Confidence in data results from students evaluating their confidence for each question. What is the maximum predicted value of y? Predicted value y. You know what? I'm going to Google maximum predicted value of y and just see what happens.
Yeah, I typed in predicted value for lesson 22 and I'm getting stuff, but just can't figure it out.
There's some concepts they want us to get. What are predictors and criteria? Oh, it shows us our formula. According to regression linear model, what are the two parts of variance of the dependent variable? How do changes in the slope?
What's the matter? What's lost? Look, Mommy's online with her friend. You see? Yeah. So you, right now, can you figure it out yourself? Mom. I need cereal. Cereal. Okay. You won't leave me alone until I do. So.
Predicted value. Maybe images. I'm gonna image. Sometimes images helps me when I type in keywords from a question. Let's see here. You know, it sounds like a very pretty. Did you try to put in 6?
I didn't. So I wasn't sure if it was something like that. We could put in 6, or even if it's like the maximum on confidence rating. Like if we went through and found the highest score for the confidence rating and put that.
Right.
But then again, that's like, so we could, you want to just do that. We'll put number 6, and then if it's not that, we'll come back and put the highest confidence rating score.
Okay. It says here variables entered removed, model variables entered confidence, rating mean. And there's no numbers attached to it. Yeah. And so it may be that, because here's the hint, because there's a positive correlation, we can use the largest x value to find the largest predicted value of y.
Yeah.
So okay. It's, I would assume.
Oh yeah, there's a 6 right there. 6 is the highest. So let's.
Right. Do you think that might be that? Maybe. It might be.
Try it. That's worth it. I have nothing else. I'm all for that.
Okay. And I'll keep looking through the book when we're done with that. Okay. How many explanatory independent variables are present in simple linear regression? Would it be 1?
Yes.
Okay. This one. How many response dependents? Oh, that's 1.
Yeah.
That's 1. This is not as bad as I thought. I kind of looked at some of it and I was like freaking out, and it's not that bad. Okay. A company in South Dakota manufactures hard hats used in the mining industry. The record, they record measurements on all the hats they produce for quality control and planning purposes. The measurements they collect include hat size, circumference of the hat, and lengths of the major and minor axes. Meaning the company wants to predict the size of hat given the circumference. What is the response variable? So, So I'm going to look at my notes for what response variable. It's the predictor. And it's also the y variable, and it's dependent. Yes. So our y variable would be...
What helped me solve this was he had said in his video, the response variable is what we are trying to predict from the explanatory, which is pretty much what you just said. So
it would be the measurements. It'd be hard hats, right?
Are you asking what the answer is? Sorry, I've got one in my.
I want to see if I can get it. Yeah, no. Sorry if I'm taking my time.
No, don't. I'm the same way. I learn if I do it myself.
I would say the size of hat.
Yep, it is the size of hat.
I would say it would be A.
Yes, you got it.
Okay.
You're so smart. See?
Thanks. You know, living with Aaron, it's a lot easier just because it's just him. And so it's kind of funny, like I was doing the homework and like I was understanding it better, and it's just because there's one person living here. It's not 5.
Yeah.
And so it's quiet. Like you're amazing, Christina. I don't know how you're doing it with 7 kids. Like Aaron's like, well, he's like, we're gonna like wait to have kids, you know? And I'm like, I'm 27, you know, and I'm kind of like, I'm gonna submit the quiz to see if the 6 was right.
You can do it. The difference too is that you get to control the atmosphere in your own home, where
It's
when
true.
you're living in someone else's home, you don't get to do that. So
I don't. You're right about that. And as a parent, you are in control. Yeah, that number 12 was wrong.
yeah,
But we got everything else right. So let's.
Yeah, it's like 90.
Do you kind of want to dig, or
I don't even know what.
Do you want me to help keep digging?
I don't even know what.
I don't know. Yeah.
One is just, I'm lost. I looked for it last night, and I was like, ah.
You know what I've done sometimes is I'll go to the next chapter.
So,
just to see because sometimes they do that. You've noticed that? Like.
Yeah, that's true. And when I looked for it, it said lesson 23 was an option too. So maybe I'll go to lesson 23 real quick.
Here we go. Theory of simple linear regression. Let's read this and see if we could learn what concepts are trying to help us understand. Here, this is interesting. When we compute an estimated regression equation, we assume that there is some true equation that describes the relationship between x and the mean value of y. This equation is unknown to us. In particular, we don't know what the coefficients are in this equation. In the estimated regression equation, we use BO and B1 to represent y-intercept and slope respectively. These 2 coefficients are estimates of the unknown regression coefficients in the true equation. We will use the Greek letter B, pronounced beta, to denote these true unknown coefficients. The true regression line, there's our formula. These are unknown constants representing the true values of the population. We know that y will not fall exactly on this line. There will be some randomness in the observed values of y, so we add a term called the error term. This equation is a random variable, and we denote it by the Greek letter. The true regression equation is, that doesn't answer my question, though. I guess the question is it okay if I read it out loud again? The confidence data resulted from students. So they want a question regarding the confidence data. Yeah. So our confidence data was, it was is BO, right? That was our confidence data. Yeah. That was the BO that represented that. Okay, 18.69. From students evaluating their confidence for each question on a scale of 1 to 6. So this data represents students on a scale of 1 to 6.
What is the maximum predicted value for these things?
So maximum means the highest. Predicted means, let's go back to predicted to see if we understand what predicted means. Let's see. I'm going to go to 22 again, just to see if I can find that. Because I remember reading predictions. Predictions means if we want to predict the number of manatees that will be killed if, say, 850,000 parvots are registered, then we enter x equals 850 in the software and compute the predicted value. So it's kind of like it's x, the predictor. I don't know if that was it. Keep having this feeling that it's in the boxes here.
Yeah, I keep going
Some
back
of the box is the answer.
To the SPSS. Yeah, that's what I keep going.
But it doesn't seem to, it's not your T-score, and it's not, here's your model summary with R-square.
Can you see it?
What do you do? What's wrong?
I don't know.
Reach what? You can't reach what? Can Emily help you real quick? Can you go ask Emily for help, please?
You know, variable. I'm seeing at the bottom of the ANOVA box, predictors, constant confidence rating mean.
Uh-huh.
And I clicked on it, but nothing really came up except for this formatting toolbar. But
I hoping so. Oh, let it go.
You're fine.
No. Just go.
they sound so cute.
She's my funny baby. Aren't you? He came in with a Batman costume on earlier, and I go, "You're Batman," and he goes, "No, I'm Big Boy."
Sounds like Aaron.
Okay. Yeah.
Oh, sometimes it's necessary to use more than one predictor variable to predict the value of a response-dependent variable. For example, if we want to predict the stubbornness for car and dry roads, we might want to use I, the initial speed of the car, the weight of the car, and the amount of tread tires predict the distance required to stop the car. I can't find anything in the book.
Yeah. And originally I had number 4.
Says here higher statistician.
I was like, oh, maybe it's 4 because X was 4 in the previous problem. So I don't know.
I'm not gonna worry about it.
Okay. Yeah, I'm okay with my 90%, but if you want to, or
I'm okay with 90%.
I'm sorry, I can't figure it out.
Oh, it's okay. I couldn't find it either.
I handed in our data, described the data. She said it looks good. So hopefully looking good is the same as getting 100%.
Oh yeah, yeah. You'll get it.
Not just me.
Yeah, I noticed she's pretty fair. If you followed every instruction and you did everything she said,
Yeah.
then she's really fair with the project grade. So I was worried she'd be like, hey, it wasn't 350 words. And I'm like,
yeah.
Because most of my professors are like, it's 350 words for that. So, but she didn't do a word count. So,
I'm
all right.
Before I have a baby meltdown out there. So.
Okay, thank you for you're so sweet, Christina. Thanks for your help on the project. And if you need any help, let me know if there's anything extra you need me to do.
No, you too. Okay. Thanks.
All right. Thanks for your help. You helped a lot. Thank you.
I'll talk to you later.
Okay, bye.
Bye-bye.